The death of God is about the drying up of a horizon of meaning and of a whole form of human life.
Where do we stand in the illusion it makes? What kind of space are we invited into?
The material relations between people become social relations between things. When we look at toasters, corn, and TVs,
we still, to a large extent, live in the interregnum between worlds, if you will, or between paradigms. Not many people in the history of the world have faced that.
Diet Soap is a Sublation Media podcast. Dr. Dwayne Monroe is a blogger at Computational Dynamic, an anti-crypto activist, and an AI skeptic. In this episode of the Diet Soap podcast, we're going to discuss, not discussed, although there may be some disgust. In this episode of Diet Soap podcast, we're going to discuss crypto coins, AI, and algorithms. Dr. Monroe, welcome to the podcast.
Thank you very much. Now, I have to actually issue a bit of a correction from the beginning.
Okay.
My initials are Dr. Monroe, but I did not achieve a PhD, although I'll certainly take it if you want to give me an honorary PhD.
Okay, I will give you an honorary PhD. And I will start referring to myself as Dr. Lane as well, although that...
Why not?
That's what my father calls himself because he's a medical doctor. Okay, so Mr. Dwayne Monroe, what is your background? Tell me how you became a digital activist.
So I am a technologist, as we say in the trade, so to speak. Mm-hmm. And I've been working with technology for about 20 years, approximately. First with enterprise systems. So that is to say, large scale systems for corporations. Earlier in my career, for example, I would participate in the design and the implementation of data centers. And then also other solutions within those data centers for companies within pharmaceuticals and law and material science. So my experience with technology goes pretty deep. And then when the cloud became the going concern or the focus of the industry, I pivoted my career to the cloud. Now, I would describe myself as a person who is becoming an internet polemicist on the topic of technology. And there are other technologists who've gone down this path. One of the most famous ones is Yaron Lanier, who a number of years ago wrote a document called Half of a Manifesto, in which he criticized the direction of the technology industry. And then also, I believe years after that, he wrote an essay about why you should get rid of your Facebook account. Now, so there is a precedent for people who actually are technologists, who understand the technology, but who see problems. I think that what I'm adding to this milieu or this mixture of people is that the position from which I'm approaching this is unequivocally Marxist. So I have, an actual technology background. I've actually touched the machines. I know how things work not everything, no one can know everything, but I'm not intimidated when people start talking about highly technical topics. And whereas some people see magic, what I see are computers in data centers running software. And this is why my engagement with the topic of AI starts from a materialist standpoint.
Okay, so how did you become a Marxist? I'm always interested to know how people came to this strange terrain called American Marxism. I'm assuming you're American here.
I am. My wife and I relocated to the Netherlands a number of years ago. So this is where we are living our life, which is actually quite good. No place is perfect, but we do enjoy our life here quite a bit. Mm-hmm. So the Marxism, I would say that in university, so although I didn't get my doctorate, I did attend post studies, but I was exposed to the concepts of Marxism through a sociology professor, actually, who taught at the University of Pennsylvania. And it made sense to me. When she began her analysis, or rather when she began describing to us some basic concepts such as historical materialism, dialectical materialism, and the labor theory of value, these things made sense to me. And they made sense to me because I grew up in a working class household. And so I was closer to seeing the vagaries and the damages visited upon people's lives by capitalist formations. So it wasn't a matter of me, say, being someone in a position of extreme privilege who then had to kind of break into an understanding. It was a person I was seeing at the ground level, how capitalist relations were damaging the lives of my family and people that I knew. Also because I knew that the poverty that I often saw was not the result of the failure of individuals or families, even if as a consequence of some of the poverty, you would have bad behaviors, or what we would call bad behaviors. I knew that it wasn't a matter of me or people who had more privilege than me being better people, that obviously there was a system that was structuring their lives in such a way that these outcomes were occurring. But the question was, when I was much younger, what is that system? And Marxism was the most compelling answer. And as with any serious field of study, it's never done. I mean, you're always learning, you're always applying, you're always trying to increase, or rather improve your praxis. And technology gives us a perfect opportunity to do this, I think, because here we see, the movement of capitalism at a really high velocity, particularly since the 1990s. And the movement in Silicon Valley is just a marvelous case study for seeing the movement and the capacity for capitalism to stay the same in its basic structures and yet also adapt.
Mm-hmm. Well, were you already a technologist, already acquainted with computer science when you came across Marxism?
I would say yes, because my attraction to computers and computer science and computer technology goes back quite a ways. For example, my first computer was a Sinclair ZX81, which was a kit computer that was made available from a company, from a British gentleman named Clive Sinclair, a pioneer in computer science from the UK. And it gave you the opportunity to do programming work, and it was inexpensive. I think I worked at a church, in the summer, cleaning the garden or whatever I was doing as a 12 or 13 or 14-year-old to earn money, to be able to purchase this thing. And so I knew from a fairly early age that I wanted to work in computation in some fashion. And I was fortunate enough to be able to do it, actually. But I was the kind of person, I think, who, even if I became an accountant or whatever, I still would, even as a hobbyist, as opposed to being a profession, would have no doubt worked and studied computers. But fortunately, it worked out in such a way that I was able to do it professionally at scale.
Well, I noticed that you've got a little bit of gray in your beard, so I imagine that for you, computers, when you first were getting involved with them, were maybe a little closer to being the obsession of the hobbyist. You would maybe get personal computers that you had to assemble yourself, or
yeah, exactly. Yeah.
Yeah.
I mean, of course, at that time, there already were, systems that were.
Oh, my computer's talking to me. I don't wonder what I said to it that made it start talking.
It's very annoying. Like all these voice responding units are extremely annoying.
Yeah.
But we, of course, we already had, large scale systems. But you're absolutely right that during the era of the homebrew computing club, and back when Gates was pretending that he was a hobbyist and not what he actually is, and so forth. It was a thing that it was something like playing D&D. It was something that, a group of people did.
Oh, no.
And,
did you do that too?
Oh, yes, of course.
Yeah, me too.
But my friends and I would play D&D, and then we would go to party. So I had kind of the best of both worlds, like the geek world, but also the world in which you went to house parties and
Cool.
Got to meet
I didn't
friends.
have the best of both worlds. I was just stuck in the basement. But so I'm wondering, do you think that the fact that you were acquainted with computer technologies and programming and systematic thinking, maybe in that terrain, did that help you grasp Marx's critique of capitalism a bit more easily? Or
Maybe, that's an interesting question. I'm not sure, but what it did give me the opportunity to do once I actually started working after graduating from undergrad was it gave me an opportunity to actually see what companies were doing. Because if you're involved in computation, you're involved in the nuts and bolts of a corporation. And you have an opportunity to see things that many other workers don't necessarily see, because you're seeing how all the elements of the company are knitted together, because computation is at the foundation of all of modern capitalist command and control and logistics. And so certainly, if I had any doubts that I was on the right track, seeing how companies actually function systematically and amongst each other certainly reinforced what I was already thinking.
So I'm going to ask you a kind of a newbie question, because you said something earlier that piqued my interest and will also expose me to really be out of my depth. But you said that when the cloud became where a lot of computer programming or the technology was going, you pivoted to the cloud. What is the cloud as opposed to just the internet?
So there is a joke when the cloud era really got underway in the mid 2000s, I'd say. A joke went around amongst techies, which is there is no cloud, it's just someone else's computer. And what techies meant by that was that all the things that we have been building within the data centers of a particular company were now being offloaded to companies such as Amazon, and then a little bit later, Microsoft and Google, Alibaba and Oracle, IBM, so forth, other companies. Cloud computing is defined by the National Institutes of Science and Technology as a methodology of providing computational services over the internet, yes. However, there are certain differences between, say, a simple website and a cloud. What a cloud is a service methodology that provides a unified API, by which I mean there is a unified fabric, a computational fabric, that provides services such as database, compute, and storage that can be elastic. It can scale to meet your need. And it's provided as a utility as opposed to something that you have to build in a bespoke fashion. So, for example, if you use Amazon Web Services, if you're a company and you use Amazon Web Services, rather than having to, build infrastructure yourself or purchase, servers from Dell and other companies and rent real estate, to rack and stack, as we used to say, these servers to provide the computational power that you need for your company. Now you are actually renting as a utility the computational power, the database, which of course is key to many things that we do, and the storage. And there's a reason why Amazon, when it began offering cloud service to the public, because it was internal for a while, it started with a service called S3, which is a simple storage service, I believe, because they realized quite early on that making storage as a service, as a utility that you could simply use, would be a foundation that would sort of hook people in. Because one of the problems that we had in the pre-cloud era was having to purchase more and more disks, more and more storage.
Could you say that again? Because you kind of froze up for a second. I could hear you, but when Amazon started offering their services, say that, start from there if you could. Could you kind of froze?
Yeah, no problem. They started with what they called S3, which stands for Simple Storage Service, because they realized that the foundation of much of what we do is storage. In fact, today, one of the most important things for what we call AI and machine learning, which is a subcategory, is the ability to store vast amounts of data, the big data that we often hear about. What does that really mean in material terms? Well, it means the ability to store massive amounts, gigabytes, terabytes, petabytes of data. And so Amazon realized in the early days that if they made storage available foundationally, that would be very attractive to organizations, which indeed it did turn out to be. And then they built higher order services on top of that allow you to write code and run websites and do all sorts of things that we can do today. But to answer your question, I guess to put a capper on it, yeah, the cloud is a way of consuming computational power, database power, and storage capacity as a service, the way that we consume electricity and water.
So it's like renting mainframe computers, basically, that are programmed to provide you with storage and services. Like Google Docs is part of the cloud.
Yes,
right?
that is a category which is called software as a service, because there's subcategories. There's infrastructure as a service, software as a service, platform as a service. All these things come under the umbrella of what's known as a marketing term of cloud.
Mm-hmm. And I used to write on Word, and now I write on Google Docs.
Yes.
And I've noticed that Word, this is just off to the side, Word is unwieldy. It's terrible. It's a really terrible piece of software.
It's a very big code base. Yeah, it's a very big, because Microsoft has to maintain backwards compatibility with a lot of stuff. Whereas Google was able to proceed, from presumably somewhat fresher code base, although, everything bloats eventually, which is one of the points that Yaron Lanier wrote about years ago in his Half a Manifesto, which is that hardware, the power of hardware increases by leaps and bounds, but software remains a bottleneck because it has all sorts of problems. But yeah, and people, have different views about this. Because the thing about software is that it trains you to work within its limitations. And then it's marketed to us as if it has remarkable capabilities. But what's really happening is whatever works with your mind. So if Google Docs works for you, because you sort of become accustomed to it, then it seems better to you. But there are people who use Word and, they're just whizzing through it because they've trained themselves to master its idiosyncrasies.
Mm-hmm. I'm going to stay on this subject for a moment longer, although I feel as though, I'm just.
Now, this is not supposed to be a tech support session.
Okay, fair.
It's fine.
But like I edit videos, and I have something called Premiere that I could use, but I find it to be challenging, and I use it rarely and sparingly because for things that I can't do on what I actually use to edit with, which is just a screen capture program called Camtasia, which is the first thing that I ever started really consistently editing video on. And it's really not a good editing program. It has severely limited, but I can use it quickly. It does, like if I try to use Premiere to edit a video, it will take me twice as long, if not 3 times as long, to do the same thing that I can do in Camtasia. So I'm misusing the software. I wonder how common this
is. It's very common. It's very common because software has feature sets, right? I think I could be wrong about this. It's been a while since I've looked this sort of thing up, but I think Word, for example, has like hundreds, maybe even thousands of like features and sub-features. And of course it's impossible, for anyone to really master this. And so, but then, a lot of it is that there's a whole field for user experience. There's user interface designers, there are user experience designers, and there's a reason for this because people have to actually work through these quirks. And that's what beta testing is supposed to be about, is to work this thing out. Remember back years ago when people talked about Apple, like, giving iPhones to, I don't know, all their employees, like new models of iPhones so they could work out all the bugs. Apparently that program isn't working too well because iPhones have all sorts of problems. But that's the theory is that, hey, we'll work out all the bugs, the user experience issues by actually, hammering the thing out. But lots of things, lots of areas of the practice, so to speak, are kind of falling down.
Yeah. I mean, this kind of is getting to the real topic of our conversation, because what I'm realizing is that that you, like The technology is training us, and it as it changes, it presents challenges to us. So like I just got a new phone a few months ago, or a month or so ago, and I find that things are going wrong with my new phone that never went wrong with the other phone, but it's
With the
not
previous phone,
the same. It's a Pixel, right? It's a pretty good phone, Google phone. But the new model, I have to pause apps every once in a while to get them to stop being in a particular, like they freeze up on me and things. I know I just don't know how to use them right. It's me.
Don't be so certain. And it's interesting that you say it's you. And I think it's common for people to do this because the assumption is that, well, the technology is advanced and foolproof, or if not foolproof, at least reliable. Therefore, if there are issues, it must be me. But it isn't always you. Sometimes things just suck. In fact, they suck more often than people really are willing to acknowledge. Certainly, the industry is not going to, Google's not going to come out and say, "Here's our new Pixel. By the way, it might kind of suck." And I'm not saying. I'm sure that there's Google partisans out there who is like, "No, it doesn't suck at all." Blah blah blah. And I don't really care about those kinds of debates anymore. I used to like 10, 15 years ago, and I'm like, whatever. But go on Twitter and have the argument. But it's important for people to know that the technology is not, it's not a done deal. We are not living in a Star Trek world. These things are very provisional. They're very, in some ways, cobbled together. And also, we're kind of decades into this now. And some companies, some organizations are beginning to lose focus because it takes money and time and effort, to maintain quality control. And I think that we're starting to see, this is something I'm working on as a bit of a pet thesis, but I think we're starting to see signs that many of these organizations that were valorized in the earlier part of the tech boom, in addition to us realizing that they are damaging in a variety of ways, such as Meta, Facebook, whatever. Also, I think that technologically, in terms of the quality of their builds and so forth, I think things are starting to, cracks are starting to show, because the scale at which they're operating requires a level of capital investment and focus that I think is difficult to maintain for decade after decade, particularly for a capitalist enterprise.
Mm-hmm, mm-hmm. So this gets us to the promises that are being made by technology. I mean, that the baseline promise is that when Apple or Google puts out a new phone, that it is in some way appreciably better, more advanced, more powerful, has new needed features. Like for me, a big thing with this phone was it had a really good camera. Right?
Sure.
But strangely enough, I have not tested that very much because the COVID mostly. It's like I don't go out to film things as much.
Sure.
But what you're telling me is that, in fact, the companies, by and large, they're motivated for a variety of reasons to only kind of create the impression of advancement.
There is advancement. I mean, in terms of microprocessors and the hardware capabilities, they do tend to improve, although I think we're starting to come up against the limits of what has been known as Moore's Law. And those limits have to do with the incredibly small scale at which they're operating. And they're starting to run into problems having to do with, an atom's worth of material. And they're starting to get into quantum areas now. But software remains an issue. For example, you could have the most remarkable piece of hardware ever, but it's just a lump of stuff if the actual software that has to make it go is still kludgy. I think we're seeing evidence that hardware manufacture continues to move forward, or at least increase capabilities. This is why you have more and more pixels on your camera. But you still have to have software to actually make it work. And there's no magic there. The software is a matter of creating instruction sets that can optimize the usage of the hardware. And this is where things often fall down. This is also, of course, the case with AI as well, or what we call AI. It's ultimately just software. that's marketed as having abilities that it doesn't actually have. And I think that once Silicon Valley got involved in that area, that's when we started to see this muddling of promise with actual capabilities, and so when Steve Jobs would get on a stage and start talking about how he was, the iPhone was changing the world. Well, yes, obviously there were some changes, and some significant changes happened the way we interact in the world, but not the kind of changes that he meant, and also it's a machine. It's not a magic wand.
So AI, you described to me what the cloud actually is and how it came to be. Now we live in a world where we're supposedly encountering AIs all the time. They're not what I would have anticipated an AI would be like, back in the day, when I first encountered an AI, it was Eliza, right? And it would give me the give me the impression of having a conversation, not too well. But
no, this wasn't the original Eliza created by Joseph Wiesenbaum. I'm guessing it was a port of that code.
Yeah. I talked to Eliza online in the 90s, right? Yeah. But I thought of it as being basically the same program as the original Eliza.
Which it was, more or less,
yeah. And then there were variations on those kinds of AIs that you could go talk to online. There's one called Alice and others. And those were all aimed at passing at the Turing test, I think. Yes. They were all just aimed at convincing you that there was a personality on the other side of the screen. And maybe you go to a website and you wouldn't know if you were being put in touch with a person or an AI. That was at least a kind of a promise that you could go and talk to maybe a person, maybe an AI. But now AIs, they sometimes talk to you, but they don't try to convince you they're people anymore. And they seem to be doing a lot of other things that have nothing to do with simulating a human intelligence. So what is an AI today? What are we being told an AI is?
So let's start at a little bit of the foundation, which is that the term artificial intelligence itself was coined at a conference at Dartmouth in 1956, at a conference of computer scientists. And it was presented as an aspirational term to define what the research program was. And in earlier decades, from the 50s through the 60s, the 70s, and 80s and 90s, the idea was that by creating kind of a library computer with the ability to manipulate, or rather perform symbolic logic, and that you would achieve intelligence. And this is called in the field good old-fashioned AI, or GoFi. These programs, or rather these research programs, all reached dead ends. And in fiction, you see representations of this idea in HAL 9000, for example. I mean, the very name kind of contains the idea, heuristic algorithmic logic. Or I think a underappreciated film from the early 70s, Colossus, the Forthorn Project. So the fictional depiction of computers represented the vision of actual artificial general intelligence, the ability of a machine to interact and understand the world as it was understood up until the mid-2000s. But each of these research programs, as I said, reached dead ends. And then AI winters, that is to say, moments when government and university funding would dry up, occurred. In the 2000s, mathematical patterns or mathematical concepts and probabilistic ideas that had been crafted in earlier decades, but which lacked the computational capacity to be realized, were realized. And so what you had was a combination of data, lots of data, thanks to the internet. You had faster processors, game processors, for example, which were not built for this purpose, but they're designed to do very demanding workloads. And the use of statistical methods. So what we call AI today is actually pattern matching. Whether it's Alexa, receiving audio input from you and then responding with canned responses, whether it's Siri, whether it's Google search, all of these things, whether it's AlphaGo, whether it's GPT-3, all these things are either lesser or greater examples of pattern matching. And that is being sold to us, however, by corporations, if we pay attention closely. Now, there's examples like Musk and so forth, but who's not worth listening to. But there are more serious people who are presenting the idea that this technology will eventually lead to actual AGI, actual artificial general intelligence. Mm-hmm. But what we've created are pointillistic, as Gary Marcus says, cul-de-sacs. So, for example, we thought that when Deep Blue defeated Kasparov, that was evidence of intelligence. But what we actually discovered was that playing chess is a bounded space of activity. It's very complicated. There's lots of different moves, and it involves a lot of brain power. But it is not something that cannot be mathematized. It's not something that cannot be turned into a pattern that can then be enacted via an instruction set on a computer. And the same thing was true for Go. And the same thing was true for the probabilistic stringing together of text, to autocomplete. So what we call AI is actually pattern matching.
Mm-hmm. And that's different from, again, just to clarify, from something like HAL 9000 or HAL 2000, because those earlier versions of AI were software programs that were programmed to use logic and to try to think.
That's right. And in the case of HAL, I mean, the fictional character of HAL embodies what the idea was at that time, which was that if we could build a system that had at its disposal all the knowledge of the world, a library, so to speak, and the ability to use symbolic logic, that the result would somehow, presto changeo, and I'm being a little bit unkind because obviously, some serious thought went into this. But the concept was that this would produce something akin to what we do, or maybe exactly what we do, or superior to what we do, because, HAL, of course, was supposed to be faster and smarter and so forth. And all fictional computers are depicted as being super intelligences. In fact, philosopher Nick Bostrom, as you probably know, released a book several years ago, Superintelligence, that presents the idea that this is the path that we're walking towards. He's very light on technical details because I don't know what he actually understands about actually existing computers, but this idea is abroad in the land. In fact, if you were to Google artificial intelligence, what you will get are images of glowing brains, robots, doing something like this, or these are the images that are abroad. And there's a reason for this, which is that the tech industry is promoting the idea that what they are building is actually intelligent. And I think they have to, because, number one, it's a moneymaker, but also they're trying to reshape our understanding of what their capabilities are away from, I would say, a materialist understanding of computation to a belief that it's like magic. And this is having real world consequences. For example, recidivism, machine learning programs, what Facebook does and so forth. All of these are examples of the consequence of insisting that these algorithmic systems have the ability to make decisions when, of course, they don't. They're simply looking at data sets and going and looking for the patterns that they have been trained or programmed to look for, and then producing the results accordingly.
So they use a statistical analysis of pattern and pattern recognition
exactly
to produce a result. Whereas the old-fashioned AI would be posed a problem like, hey, what's the name of this song? Look at the data sets and then use logic to try to theoretically to deduce what the correct answer
that was. The idea, yeah, that there would be, like you say, well, you would pose, if fictionally you would pose a problem. I'm wet. What there's a lake nearby. I'm wet. What possibly happened? And the idea, the hope was that you could create a system that would then be able to logically infer, well, perhaps you were in the lake, as opposed to go through, a massive data set of pictures of you and the lake and so forth, and then kind of make a crude correlation, but not even really a correlation, because correlation sort of implies thinking. And really what we're just talking about are training sets built upon massive amounts of data and the statistical analysis, the methods that we all learned in high school and college, linear regression and so forth. All these things are coming into play. I mean, and there are newer forms of math as well, but it's all based upon the same trunk, or coming from the same trunk.
Mm-hmm. And so the fact that we don't have thinking machines is consequential, because it means that, well, for one thing, if you pose a problem to an AI that isn't just a one that's already been solved, say, that isn't in the data set, it's not going to be able to think for up a solution. It won't be able to be innovative or creative.
And this is exactly why self-driving cars, self-driving autonomous vehicles remain a challenge, because the most successful examples of that, such as Waymo, or what Waymo has done, I think, in Phoenix, involve a combination of mapping, sensor arrays on the vehicle, and a bounded space. Right. So it's, so you've created a training situation or a programmatic situation that allows the machine to navigate a space that it's navigated in a simulated environment. And as long as everything stays, exactly the same, it's fine. But the moment you say, well, now, Waymo car, take me to, I don't know, drive me from Phoenix to Los Angeles, it's impossible. And in fact, behind the scenes with Waymo, there's this army of people in a data center observing everything that happens, because they realize that, the platform does not have the ability to make any decisions. It's simply running through a program, essentially.
That's very, so
but
in a way,
but it looks very impressive. And this is, and Doug, I'll tell you that the reason why I started doing this is because I was watching an episode, and by this I mean, becoming kind of a lefty tech polemicist on the internet. Is I was watching an episode of This Is Revolution, and Pascal Robert commented on the potential for self-driving trucks perhaps having an impact upon the political economy of logistics, and maybe an impact upon truckers as workers. And I believe one of the guests was Angela Walker, and she said, and she's a trucker, as I recall, and she said, absolutely not. Like, that's just it's not possible, because of all the environments that I operate in, there's no way a computer could do that. And I don't know if she's familiar with the research, perhaps she is, but she's absolutely right that a self-driving truck is just completely beyond our capabilities, but not only beyond our capabilities now, but beyond our conceivable capabilities, because we have no idea of how to do that. And
we'd have to have a paradigm shift.
Precisely. I mean, Melanie Mitchell, who's a computer scientist, has said we are an innumerable number of Nobel Prizes away from being able to even begin to have this conversation. So we don't even know how to begin. And that's
well, I mean, the other way to go about it would be to have more control over actual space.
Yeah,
in other words,
and it's interesting you say that.
To put it differently, it's like what you are really doing with these self-driving cars is creating a kind of mass transit where there are tracks and everyone's got to stay on a track. Right.
And wouldn't it be simpler to simply say, let's all use a train or a bus?
Exactly. Yeah.
It's like, you spent billions and you put sensors everywhere, but you just could have gotten on the damn bus.
Exactly. Yeah.
And what's interesting about this, what you just said, is that many of the companies who are in this space, realizing that their highfalutin claims of only a few years ago, which, by the way, have an impact on their stock valuation and all of these things, that the way to solve the problem of the fact that they cannot build self-driving vehicles is to just put censors on everybody. And I think maybe Biden or maybe it was Harris or Buttigieg, I think might even have spoken about this a couple of weeks ago, that there would be censors, to protect people from these terrible non-thinking systems. Say, well, if there's a censor on you, then it won't hit you. It's like, so you would spend trillions on these stupid censors instead of just saying,
why don't you just have this gate that goes down over the tracks, or to keep people from the tracks when the train's coming? It's you know what I mean?
It's absolutely ridiculous, but it does show you how ridiculous and also dangerous this space is. And one of the things that I strive to do on Twitter and elsewhere, and is help people to understand that when we are analyzing this space, we need to ask the right questions. So, for example, if a Musk says, I'm going to get us to Mars and build a Mars colony, you'll have a number of people write like all sorts of elaborate, essays and analyses about, Musk's plans, to build a Mars colony and what that means, and, for the labor theory of value or whatever. But the real question to ask is, well, no, that's not possible. He can't do it. Right. Why don't you save your energy and focus on what the actual harm is? And this is my approach to what we call AI, is the actual harm is not super intelligence or people being replaced by automation. The real harm are these primitive systems being placed into decision-making flows, and then obscuring culpability from governments and corporations, because they can say, well, the AI, did it, as opposed to the company or the people who decided to put this terrible system in place. I mean, I'll give you a real life example. Here in the Netherlands, there was a benefits determination system that was put in place a number of years ago, which I believe was fielded by IBM. And the system was marketed as and assumed to be flawless. And as a consequence of this system, many people were flagged as being, getting benefits that they were not entitled to. And there was no appeal, and there were no people in the loop, which is unusual for the Netherlands because typically people are always in the loop. And there were many terrible consequences. There were people who lost their children. I think there were some suicides. It was the current government, or the previous government, was under, of course, a lot of scrutiny because of this. It's a great scandal. And at the heart of that scandal was the assumption, probably starting as marketing propaganda, that this system will alleviate you of the burden of having to go sift through thousands or millions of applications for benefits. We can algorithmically determine whether or not people are eligible, and then you can just relax because the system is flawless. And these are the actual kinds of harms that are happening to people today. And that's why I get frustrated when people on the left, when they analyze the tech space, that they look at these things that either are not happening or cannot happen, which are sexy, though. Like what will be the impact of these exotic, non-existent technologies on people's lives, rather than looking at the actual harm that's happening today. And there are people doing this, but it's mostly technologists who are concerned, and I think that it's a rich field of study for Marxists to actually analyze the Silicon Valley and its activities, but one in which it's informed by an understanding of what they're actually doing. In other words, we're supposed to be materialists, right? So we should look at the actual material situation, and then build our analysis from that.
What do you make of Zuckerberg's Meta move?
I wrote about this in my blog, and it is, of course, nonsense, but it does bear watching because it's not achievable as described. And this is a phrase I use often, that whenever you're presented with a technical concept, you should ask yourself, who benefits? Is it achievable as described? And if it is achievable at all, what would be required to make it achievable? In the case of Metaverse, putting aside the fact that he's just borrowing a term from, I'm sure as a science fiction guy, Neil Stephenson novel Snow Crash, which I read when it was first released. So when I heard about this, I'm like, Jesus, really? Dude, it wasn't a good thing. But of course, you're not a good person, so I understand. I understand the combination of the two. But it is not technically possible as described. And what we do have, of course, is what was already done in Second Life and what was done through the Oculus Rift and the VR environments that are created for that. However, I think that what they're going to do is try to find ways of monetizing this, and they will present it as if it's, and we're already seeing this, like people are describing what is essentially the same stuff, but they're rebranding it as Metaverse. And there's a few minor modifications where, you've seen the comments.
Just to be clear, what are the claims he's making we can achieve? That we can create a world, right, that people can live within to a large extent, using what, an Oculus?
Essentially, because of course, there's some sort of patent,
or maybe augmented reality glasses or something like that. As well.
So they have the Ray-Ban Stories glasses, and they also have the Oculus because they purchased that company a while ago, as we know. So some combination of those technologies, but some a combination of haptics, that is to say, gloves. Goggles or glasses of some sort. In fact, in the blog post, what I did was I actually took a look at their job listings, because if you want to understand what a tech company is up to, one of the first things you should do is look at their job listings, and look at the categories of people that they're looking for. And so Meta is looking for, haptics engineers and server administrators and psychologists and so forth. This is the job listings that are being posted. So the idea is that it would be a totally immersive environment, obviously not as immersive as Star Trek's holodeck. Although it's interesting that in the introductory video that Zuckerberg presented, he basically is in kind of a holodeck-like environment, which of course isn't possible. But even at the modest level that they're talking about, it's not possible because for very practical material reasons. Right now, I think the Oculus VR environment is serving out maybe a few hundreds of thousands, maybe a few million people, perhaps at best. We're talking about, billions of people or hundreds of millions more people who might potentially, at least ideally, they would like to have on this system. This requires an increase in computational capacity by orders of magnitude. In fact, Intel recently, an executive from Intel recently released a paper saying exactly that we do not have the computational capacity to achieve even a modest version of what Zuckerberg presented. Now, of course, Intel has skin in the game because they're hoping to sell hardware, but that doesn't make the assessment any less true. And my prediction is that eventually the Metaverse will probably end up being mostly an internal Facebook thing that they force their employees to use. And then some companies will use it for conferencing and things like that. And they'll try to market it as a way to do cool stuff, but it'll probably fall flat eventually.
Okay. I'm going to ask you a question that's very self-indulgent, but in my novel, there's an actual AI, and the AI is given the task of saving humanity from itself. The AI predicts that if things keep going the way they are going, Trump will start a nuclear war with Russia. So we've got to intervene. So the solution is to break with capitalism by creating an augmented reality, which everyone would live in. And everything they did in that augmented reality would revolve around video games. And the video game then would also be a form of production.
So this is Bash Bash, right?
This is Bash Bash behind me, yeah. And the video games would be a way that you would play the video game, but you'd also be creating computer chips and Soylent and helping to produce more porta potties. Because in the
real world,
in the real world, right? And and this becomes the way people live. And
wait, Soylent, porta potties, these are the only jokes.
you create, well, you're playing a game, and you create, and maybe you're helping to keep the electricity running for the sleeping chambers wherever they're like. I don't think I even wrote about that. And yeah, everything's very, sex is a very strange thing in the new world, but
I can imagine,
but because you don't really see each other exactly, not in an unmediated way. But anyway, does any of that sound remotely plausible to you, or is that completely off the spectrum of the possible? Because well, one, the AI itself couldn't exist.
Exactly. And so a system that could make decisions and reach conclusions. I mean, you've basically just spelled out the plot of Colossus, which, if you've seen it, I guess you do, because I think you would enjoy it. It's from 1972, I think it was.
I have not seen it.
Yeah, it's a quite interesting Cold War era movie, because in that movie, and I think War Games probably borrowed its idea from it to some extent as well. But in that movie, the United States and the Soviet Union create parallel supercomputer systems that control their nuclear arsenals. And Colossus is the American one, and Guardian is the Soviet one. And these two systems independently decide that, hey, you know what? We were built to prevent humanity from nuking itself, but maybe the problem is that humanity is in charge. So let's use the fact that we now control all these nukes to force humanity to be better. And so they craft a kind of a co-dominium of the Earth based upon these two supercomputing systems. But yes, the problem is that in reality, there's no way to get a system to make to assess our situation. We could create a program. We could create some kind of jangled together system that would then present some kind of answer. I mean, people do this with GPT-3, which is the language model platform. People do this today with GPT-3. They'll ask it questions like, will humanity destroy itself? They'll type in a question, and it'll gather text from its language model and then assemble some kind of answer. You could do that, but of course, there's no thinking. It's simply assembling text. Yeah. I know that it would be nice if we could build such a system, but the first step would be for us to understand ourselves. Like we couldn't just stumble into building a parallel intelligence without understanding ourselves, and we are a very long way from even understanding ourselves.
Yeah, I recognize that every day, just about myself. I feel like one of the major topics that we were supposed to discuss was cryptocurrencies, and we haven't even come close to that yet. We're about true. 52 minutes in. Here's what I'm going to do, and this is devious of me. I want to take a break, give you another link in about 10 minutes. Mm-hmm. Tell me if you have time. Can you do this? Is this okay?
Yeah, I have like another 30 minutes approximately. Yeah.
Okay, great. So a 30-minute session. And we'll talk about cryptocurrency, and I'll put that up for patrons only. Okay. And you can let me have it about cryptocurrency. So I'm going to stop the recording here.